MIT professor Edward Lorenz famously asked the question, can a butterfly in Brazil cause a tornado in Texas? The answer to this question is unambiguously yes. This is the difference between two slightly perturbed simulations of weather after 4 days. The difference in the mean sea level pressure is around 60 pascals. After 15 days, the difference has amplified 600 pascals. After 31 days, the difference further amplifies to thousands of pascals. Here, we are asking a more difficult question, a more difficult task for the butterfly. Can a butterfly control the climate? Changing the weather in comparison is easy. Even a tornado is just a blimp in the weather evolution. Controlling the climate is changing the long-time average, the long-time statistics of the weather. Let's think about the consequence if the answer to the question is yes. What if a butterfly, through such a tiny perturbation of its wings, can control the climate? We can use such subtle controls to mitigate global warming, to improve food production, and to reduce the frequency of natural disasters, extreme events. We can do this in a much more subtle way. Let's consider different methods of affecting the climate. Think of the y-axis as the amount of artificial perturbation we put into the system, and x-axis as the amount of information, modeling, and the prediction that is required to use that method of climate control. We can create a nuclear winter that requires very little information, modeling, and prediction. You just block out the sunlight. That requires a lot of artificial perturbation. Of course, that is not what we want to do. We want to move towards right lower part of this diagram. For example, we can perform carbon capture. That requires more modeling, less artificial perturbation. If a butterfly can control the climate using very subtle perturbations, it requires a lot of information, modeling, and prediction to the system. This small effort, very smart control can achieve the same effect as a large effort controlling the climate. So it is a very important question whether a butterfly in Brazil can control the climate. You may be tempted to answer no. The first argument is ergodicity. If you perturb the system just at one moment and let the system evolve after the perturbation, you are going to get the same statistics. Think of another argument by shadowing. Shadowing says that if you perturb the system, even though it's a persistent perturbation, not just at one time, there is a trajectory that shadows the unperturbed trajectory. The statistics of the perturbed trajectory is going to be very similar to the statistics of the unperturbed trajectory if the magnitude of the perturbation is small. There are another camp of arguments for yes, a butterfly can control the climate. Ergodicity is not applicable here because we are not talking about a one-time perturbation. We are talking about a persistent perturbation. Shadowing also doesn't apply here. The shadowing trajectories are non-physical trajectories, so their statistics is actually not representative of the real statistics of the perturbed system. Most importantly, we have evidence in model systems. By very small perturbation, we can change the statistics significantly.